This is exercise 629 in MyLabs Plus, where we're asked to construct the indicated confidence interval for the population mean using the t-distribution. And the reason we are told to assume that the population is normally distributed is because these do not provide valid confidence intervals unless we know that fact. So we're given the confidence level as 90%. We're given a sample average X bar of 14.9, a sample standard deviation of 3. Notice it's S, not sigma, which is why we have to use the t-distribution rather than the z-distribution or normal curve. And then N is 8. The basic model for a confidence interval for a mean using the t-distribution looks much like that using the normal curve. The difference is because we do not know sigma and are using S, then we are in the t-distribution, which is a bit of a sloppier distribution. And so it's a bit flatter in the middle and fatter in the tails. So our critical values will be different than they would be if we were using the normal curve, especially with smaller sample sizes. Well, clearly I have an X bar given to me of 14.9. I'm going to need to get my critical value from the t-distribution using a different table, which we'll do in a moment. My S, though, my standard deviation of my sample was 3.0, and that's divided by square root n, which would be divided by square root 8. So now the critical value. Well, the t-distribution is different for different sample sizes. In fact, it's different for different degrees of freedom. Degrees of freedom basically are just the sample size minus 1. So in our case here, our sample size is 8. So 8 minus 1 is 7. So we're going to go to our table of critical values for the t-distribution, and we're going to look up 7 degrees of freedom. So here is our t-distribution table from our e-text book that can be found in the multimedia resources in the appendix, or in the appendices in the end of the book. And we're looking for, as I said, 7 degrees of freedom. So you notice over here on the far left, we have a column labeled degrees of freedom, in this case 7. And this confidence interval has a level of confidence equal to 90%. So what we can do is we can look in the two tails row, because a confidence interval always is intended to capture a middle percentage of this distribution, which leaves out not one tail but two tails. So if there's 90% in this, then that means that there is 10%, or 100 minus 90%, in the non-shaded region, which is the two tails. So we want to go to the two tails 0.10, because 10% is 0.10. Follow that down here to the row for degrees of freedom 7, and here is our critical value for this t-distribution. So we're going to substitute right in here that 1.895 value. What that's basically saying is that in the t-distribution with 7 degrees of freedom, we need to go out 1.895 standard deviations from its center in both directions in order to capture the middle 90%. So as our confidence intervals always have, we're going to have a lower critical value, which we'll get by typing 14.9 minus 1.895 times 3 over root 8. And we get a lower critical value of 12.89. We'll do the same to get the upper, I said critical value, I meant to say lower limit. We'll do the same thing to get the upper limit of our confidence interval, except we'll change that minus in front of the critical value to a plus, and we get an upper limit of 16.910. So we can basically say that we're 90% confident that the population mean is somewhere in between 12.89 and 16.91. Shaded region